Francis Sideco with TIRIAS Research. I'm here with Nakul Duggal, who is the group GM for Automotive, IoT, uh,
Cloud computing.
and cloud computing. That's right. So we're here at Embedded World North America, and Nakul is gracious enough to spend a few minutes with me. So Nakul, there's a couple of announcements that you guys made. So maybe we could start first with the IoT solutions framework. So maybe you could tell us kind of what it is and what are you guys trying to do with that?
Yeah. So one of the problem statements, obviously, with IoT is the fragmentation. How do you reach developers? How do you break the problem statement down to a use case,
Yeah.
to something that somebody wants to go solve for? So what was very important for us was, first of all, to make sure that developers can find simplicity in using our solutions. Our solutions are designed for a variety of different problem statements. So to be able to abstract the hardware and break it down into the usability aspects of the hardware was very important. The solution framework allows you to be able to do a couple of things. Pick the chip that you want for the specific workload, the specific use case you're trying to solve for.
Yeah.
Start to develop your application, assuming it is an AI application, which a lot of applications are today. Pick the model that you are interested in. We announced the AI Hub in March of this year. And the idea behind the AI Hub is essentially to be able to simplify the problem statement that the application developer has in terms of what they're trying to solve for and what will actually work on the hardware,
Right.
right? Because that is usually something that is not easy for a developer to be able to figure out.
Yeah.
That's what the AI Hub takes care of. Once you figure out how to go pick your specific model, you start writing your application. A lot of applications today are written in containers.
Yeah.
So you want to take an application that you wrote for a different environment, port it over to an environment that you have now selected. So we offer a containerized framework, and then you define microservices that allow you to control your container. So that's what we are announcing. That's what we are deploying. And we are able to offer this across a wide variety of applications. So you can do this with robotics. You can do this with video surveillance. You can do this with industrial inspection. And the reason why we have used the word solution is it goes across multiple verticals. It goes across different types of use cases. And so we are pretty happy to be able to announce this alongside the IQ series,
Yeah.
which is the family
Which
of
we'll
chips
talk
that we
about it.
announced.
Yeah, we'll talk about it next for sure. Real quick though, before we get there, you mentioned the AI Hub. One of the great things about AI Hub is the device farm.
Yes.
So do you anticipate some IoT
Absolutely.
embedded devices, or are there already some
we
that
already
are already
have
there?
so we already
Okay.
have the 6490. It's been on the AI Hub device farm for some time.
Yeah.
And that's the whole idea. We will make the devices available to our developers, so you don't even have to have the device in hand. You can
Yeah.
just start using the device farm. The devices are all hosted there, and that allows you to be able to try out what you need to before you get the device in hand.
Yeah. So aside from AI Hub, I think the press release and at least the quote that they had you talking about was talking about being a trusted advisor and implementer across the ecosystem. So does that mean Qualcomm is also going to start doing maybe some consulting or systems engineering work with your customers, or how do you foresee that actually getting implemented?
Well, I mean, we as a company partner very heavily, right? So I think we are known to build ecosystems. We are good at building ecosystems in our history, and what that requires fundamentally is to be able to get very close to the problem statement. You really have to understand what the holistic problem statement is for the customer, really for the industry that you're trying to go work with. And many a times we will actually say, how much of this can we do ourselves?
Yeah.
Does it make sense from a business perspective to do this ourselves? Are we solving enough of the problem statement for others to be able to take what we are building? And like I'll give you an example. We have added safety support to a lot of our chips. Why did we do that? Because we understood that our customers wanted to use our products in environments where safety was a must-have. Well, we were traditionally not building chips with safety. We added that capability, so we had to spend a lot of time understanding what that actually meant. So a lot of this really comes down to, let's stand in the shoes of our customer
Yeah.
and see the world from their eyes, and then figure out what do we need to do different ourselves versus what do we need to enable others to be able to do it.
It's amazing that you say that, because the more things change, the more things stay the same. And I remember working with Qualcomm, back in the CDMA days when you guys basically, you needed to do it all yourselves until you proved it, and then you divested whatever.
I've been
The
at
Q. I had a QCP 800. Let's put it that way.
I've been at Qualcomm since 1995, so I'm familiar with what you're talking about.
Perfect. Well, so you mentioned the IQ series. Let's talk about that a little bit. So, is this based on kind of the Snapdragon architecture
It
that
is.
you just modified,
It
or
is.
is it purpose
It is.
built for
It is.
IoT?
It is.
Okay.
So, what we realized as we started to look at the industrial space more and more is, first of all, there is a massive need in the industrial space for there to be products that are high performance, but that meet the operating environment requirements, that are intrinsically designed to be safe, that provide customers a tremendous amount of canvas around which they can experiment. Cameras, AI, multimedia, displays, the ability to be able to do whatever it is that they wish to go do with these products. And that is traditionally not what people have been designing for in these products. So the IQ series can do everything from running an AI edge box for simple analytics to being inside a robotic uh, uh, sensor that is going to look at hazardous conditions, to running computer vision algorithms at the edge, to sitting inside a drone and doing an automated survey of your environment to figure out where the risks are,
Yeah.
and everything in between. It can run a programmable logic controller, it can run a manufacturing robot. And the reason we picked such a broad set of applications is because we do believe that the use cases are endless.
Yeah.
They're endless because the assessment of the analog environment that exists in the industrial space
Yeah.
and its translation to what is the digital fingerprint that is generated on top of which you can apply AI, that's an infinite use case
Yeah.
environment. And so we had to pick the right type of processor family, and you combine that with the solutions framework, and then connect the right customers into it. Now that's a very interesting conversation to start to have.
So with that wide range of use cases, I think I know the answer to this next question, but I'll ask it anyway. The thing has 100 TOPS of NPU. That's pretty powerful. What was some of the decision making process that went into
Robotics,
that? It's robotics.
I mean,
Okay.
look, you can't really predict, and we have chips that will do more. Right?
Yeah.
We like so we've announced a certain family of products, but see, the point, frankly, is the following: there is so much that goes on at the edge in an industrial environment,
Yeah.
and what I come. I've spent a lot of time in automotive, and the term that we use in the automotive environment is, what is the environmental model around you?
Yeah.
How do you sense the environment around you? So it is very sensor heavy, and in an industrial environment, the sensors have different modalities. For example, uh, smell is a sensor
Yeah.
because gases
Yeah.
are things that people care about. Temperature is a sensor because in the presence of a gas, if you don't have the right temperature, that could result in an accident. So for us, it is about a multimodal world that should be able to take into account any kind of sensory input, and then be able to figure out at the edge what is the actuation that is required. Or if it has to go back to the cloud, who do you have to go inform? Or if you are in an environment around you that doesn't have connectivity, who do you inform that is close by? If there's a human close by, how do you inform? So for us, a lot of this is about how do you predict the environment that is around you to be able to make decisions in as low a latency as possible to be able to go have the right outcome. And so the processing for us is really a nature of, let's not get into a situation where you didn't have enough headroom
Yeah.
to go do that. And the use cases will come.
Yeah, for sure. So given all of those, both very specific but also diverse set of requirements for all the different applications you're using, what did you have to do a lot of when you tweaked it from the Snapdragon architecture to this application? What were some of the things that you guys had to do to make it, aside from doing the tops where it is? What other types of things in the architecture?
So I think the most important thing that we look at is reliability.
Yeah.
Right?
Okay.
So the DPPM requirements for these chips are, we have a very strong heritage now with automotive.
Yeah.
So we understand how to do quality at very complex process nodes.
Yeah.
So that is foundational. The other foundational capability is safety. So these are all products that are designed for SIL 3, and you can run the most advanced safety applications. Then beyond that, it's really the dimensioning of the processor. And Snapdragon is known to be a very evenly balanced processor in terms of CPUs, GPUs, NPUs, DSPs, audio, multimedia,
Yeah.
displays, sensors, and we went heavy with AI because for these types of products, what you have is a very large number of sensor inputs that you have to provide. You also have nowadays a multi-stage AI need. So, for example, you have to be able to do a first level of processing
Yeah.
and then apply a second level of processing, and there is a lot of concurrency required. So, you can never really have, in my mind, enough edge AI processing. The other piece is it has a very interesting range of thermal dissipation that it supports. So we can go for, there are 3 processors that we launched, but at the highest end,
Yeah.
you can run it at 10 watts, you can run it at 40 watts.
Yeah, you need
So
that,
the ability to be able to figure out what you're going to go do with it, that is also extremely tunable.
Yeah. I would think, the other subsystems too, like memory, especially with AI, memory, all the I/O that goes along with it.
We can run, we can run up to 7 billion parameter models locally on the chip without having to go to the cloud.
Yeah, that's great.
So,
And for robotics, frankly,
yeah.
you need that, right?
Yeah.
They need to be able to think, right?
There are lots
right
of these
on board.
applications where the need to actually go to the cloud is not there. Sometimes you do not want to go to the cloud
No.
because these are highly secure environments
Yeah.
where connectivity is actually something that is considered a risk. So we've designed these platforms to be very self-contained,
Yeah.
and they are very thermally efficient. They are designed to be highly customized by the customers that we work with, and that allows you to be able to have tremendous amount of flexibility.
Perfect. Well, it seems like it's going to set you guys up for going into this area and really expanding that out.
That's what we're hoping for.
Yeah, congratulations on
Thank
these
you.
announcements.
Thank you.
Yeah,
Nice to
cool.
see you.
Nice to see you too.
Thank
Thank
you.
you.